Hi, my name is Simon Poland. I'm a senior lecturer in biophysics at King's, and I lecture on the Visualising Life from the molecule to the cell, and also provide the practical series. The module is to provide students with a fundamental understanding of a number of techniques which allow visualization of molecular and structural detail. The practical series itself provides students with an opportunity to get hands-on experience in a number of these microscopy techniques that we also teach in the module itself. In the first workstation, the students get the opportunity to get hands-on experience in the use of a workhorse fluorescence microscope. They're able to place a number of samples onto the microscope and get an understanding of how each of the individual components in the microscope function. The second workstation allows the student to actually build their own microscope using 3D printed parts that have been put together along with some optics, and this provides the student with the opportunity to understand each of the individual components and how they come together to actually make a microscope. So they're able to build a number of different microscopes with these individual components. I would say that this was developed originally from a group in Germany. It's known as the IC2 project. And the third workstation, the students get the opportunity to go to the Microscopy Innovation Centre. The centre was set up to develop new research, advanced microscopes for utilisation in a number of different research areas in cell biology. But the students get hands-on experience in utilising one of the advanced microscopes there as well. So I think it just gives them this opportunity to see a wide range of different microscopy techniques which we teach in the module as well. So I think with this hands-on experience, I think it basically allows them to obviously learn in a great more detail than you can just in a lecture environment. Yeah, I think they're extremely enthusiastic. I think the prospect of building a microscope on your own and then utilising computers such as Raspberry Pi, components as well in order to actually acquire an image. I think sometimes the students were actually quite excited to use their mobile phone as part of the microscope. And I think one thing I would say is that I think it's very difficult to understand some of these concepts that are alien to some of the students, or maybe they previously haven't been exposed to that. And the great thing about this practical is it does give them this hands-on experience, and I think I think you tend to learn more through experimental application than maybe just reading the book and attending a lecture. And I think that's what we're trying to provide with this.